Okay, YouTube should be able to pick up the stream now, so welcome everybody. And this morning I streamed part 1. Actually, I solved part 1 for day 22. And I ended on having some debug info where I tried to figure out if there was a way to spot a pattern, etc. Well, it turns out that pattern, and I tried a few things. Some reminder of an earlier problem where you created div tables. So I was like, hey, let's try that and see if that gives us any information. But no, that didn't really help. And then I was like, you know what? Let me just print out the state. So I did this, and then I started just printing every step, just to see if we can see how it grows. And as you can see, it starts to grow and start to grow. And one thing that I wanted to see is if there would be a pattern that let us fill an entire block and then see if we can step out when it does the next range. And I believe that I found that, which happens at, let me see, I think at step, it was a little bit earlier. Let me see. I think this one is probably the first one where all of the edges are filled in, right? Nope, a bit earlier. Let me see here. So at step 14 is the first time where the entire perimeter is filled in. And this might look a bit weird, but what I did was use 2 hexadecimal characters to be able to have a somewhat concise way to print it out. So every 2 squares here is actually 1. So if you see 4, it's just 2 on the original input. And Mate is here. Good evening, welcome, good to have you. Did you make any progress on this yet? I was like, after I put the kids to bed, I was like, okay, I want to try this again and see if I can actually come up with a solution. So if you can see here at step 14, and this is just me blowing up the original grid and adding 3 to each side. After step 14, we have this square isolated. But since it will be a new situation when it encounters this one, you can't really tell much from this. So my idea was, okay, let's see if we have one full square around the starting point filled, then we should have a pattern. And Martin says, finished my dinner not too long ago. Ah, okay. I hope you had a nice dinner. So looking at that, you can see it grow and grow and grow and grow and grow until we get to step 29. And it's like, it's almost there, but there are still a few, like here is a few steps that are missing. Here is a case that's missing. And at step 30, this one above it, to the left, right, and below it are fully filled. Actually, it was earlier. Oh no, here there was a gap here, but these one filled up a bit earlier. Now that I look at it, but for me, I was like, okay, after step 30, there are no holes in the pattern. So like here was a hole, and up here this is not really a hole, but this is actually a hole. And after step 30, these one are filled in, and there's no holes in the pattern. So what I did is look for the next time this happens. And this is 11 steps later at 41. Let me pull that one up. So here at 40, you can see there's a hole here, there's a hole here, just like at step 29. But at step 41, which is the grid is 11 by 11, at step 41, it's fully filled in again. And now you can see a pattern emerging here of full squares that we can count and some partial squares. So then what I did was, I looked at the next step as well, so that would be 52. And at 52, it's already bunching up on the edges. Like you can see here, it should have had more room to the top. But you can see 51, there are gaps, 52, it's solid. So this is a pattern that repeats. And this was for me the sign, like, okay, let me just make sure that there are no holes and then try to fill out the entire thing. But looking at it now, maybe I need to have an earlier pattern, because what I wanted to do was take the big example here, 41, and see if I would slice this up, if it would let me build out parts that repeat and as they grow, that they would work like that. So let me see. Amarte asks, so does it repeat every column time? Yes, it does. And let me show you. I made a drawing on Discord. Let me just pull it up here. I made this amazing MS Paint drawing. And basically what you can see, this is the center tile. And this irradiates 2 to each side and 1 diagonally here. And then you have a few patterns. You have these 2 are the same. So if this one will grow once more, there will be 3 of those in this pattern. If you shrink it all down, there will be 1 block here. I will show you on the 30th here. Then you have these 3 edges that are the same. These 3 edges are the same. These 3 edges are the same. And these 3 edges are the same. And then you have this one, this one, this one, and this one are unique. So you have north, east, south, and west, which are unique combinations. Then you have the diagonals in between at the edge, which repeat. You have the squares below them that might not be fully filled. Those repeat as well. And then you have the ones that you are sure that are 100% filled. So if you look at the 30 block, you can see the same pattern here. This one is fully filled, this one is fully filled, this one, this one, this one. Then this one is the one that repeats twice in the other image. This one is the one that repeats twice in the other image. Same for this one and this one. And this one are the 2 side pieces that are repeating. This one is the south edge. These are these 2 blocks. This is the one that repeats twice. Then you have this one and this small area. Those are the side pieces that repeat. This is the east edge. This is the northeast sides that repeat. This is that 1 block that repeats twice in the other, etc. So you can map it 1 to 1. Now the trick is, there's a few things that get tricky, in my opinion. First, what I wanted to do is make sure to find this state. So this one is the first time that there are no gaps. To do that, I would need to map out every spot, and that is a bit of a pain. So I might have to do it differently and look at the other relative spots. Because my idea would have been to like have a 3x3 grid that's fully filled in and try to take that as the repeating pattern. And I think that everything repeats, so it should be possible. So looking at this one, if I want a full 3x3 grid, and actually you don't need a full 3x3 grid because you just need this, the cross to be perfect. After that it should be fine. So what I need to do is actually have some logic that will let you give an offset to a grid and then check if every possible spot is filled in. So I will do that, I will start coding that shortly. But for now, let's see the first time that this happens. It's not stable yet. There's still, this one is completely filled up except for this spot. The bottom one here is not filled in yet. Still not filled in yet. 28 still not filled in yet. So 29 is actually the first where you'd have this cross filled, right? So you have this one. It's hard to mark out. Let me just grab this. So in this case, at 29 is the first time that you have this one fully filled in. Which means if you take 11 steps after this, this should repeat exactly like this. So then you'd have, this one is a special case that will repeat like this. You'll have, these ones are unique edges. I should probably give them all their own color, but you get the idea. and this one. And then you have these ones here. Let me see. But in this case, this one doesn't repeat. Oh yeah, I was messy writing this one here. So it does the 1D like this. It repeats here in the same way, right? So if you number the pairs, this would be 1, and this would be 2, this would be 3, this would be 4. This is 5, 6, 7, 8, 9, 10, 11, 12, and this one, these are 13, right? So these are the unique groups that you have to track. So you have 13 groups that repeat like this. And this one is stable from the moment that these ones are. I think the easiest way to track them is from the moment that they are like this. Now the only issue that I have is that if you take a point, a stable point, that's not from the that doesn't align with the amount of steps that you need to take, that you will have to construct that state in the end with some like edging to make sure that you can't double count something, or just let it grow from there and then do a deduplication at the end, that you do a few final steps after that, so that you just take, for instance, you take all the outer numbers, or just the ones with the highest number there. Does that matter? Basically, you would take everything that's not part of this cross, so maybe you reproduce all the values in these edge cases here, and then you continue the walk up till the cycle is completed, or something like that. But maybe the easier way would be to look at how many steps you need, divide that by the amount of sides. So from this one, let's see, we need to have this divided by 131. So 20,003 like this. Let's see. 202,300 divided by 131. Wait, what am I doing wrong? No, I need 202,300 times 131 is this. And then we'd have a remaining 65 steps. Okay, yeah, because that would be from the edge to the outside. Okay, so for this is perfectly constructed probably for the test input. Maybe not, but basically that would mean if we would start at 65, we would then be able to do just 202,300 times the stuff that we did before, and get to the number that we need to be. So looking at the state, do I still have the state? If I go to 65, and of course this is the test input, not the real input. I don't think I will be able to see much at state 65 because this is too big and I would need to grow it. But basically I would have to go to this state and then do the same. I would kind of like to see it still though. So let me see, if I change this code, let me stop it here. And let's just do 65 in this case. Let's do 64 to 66. And let's grow our grid a bit more. So we go 6 wide. Let's see how that looks. it's big. Oh yeah, I should have probably not made it that big, now that I think of it. But yeah, it works. Oh, let me make it bigger. Boom. So I'm just wondering if I look, this is step 66, because it spills over into another one. That makes it kind of annoying. Because that would mean that I have to do like a slice like this. Would it make sense? I think that would still work. No, because it overflows into this tile here. So this is an inconvenient number here. So it's a bit harder to read, but more manageable, yes. Oh wait, I said 65, right? Okay. So 65, does it still have that issue? No, I don't think so. It doesn't spill to the, it doesn't spill over the edge, so this is fine, I think. Yes, it will do the same pattern here, and it won't touch the new tile. So I think this one can be sliced like this. So you'd have this, and then this would repeat every time for every corner case here, like this one, this one, this one, this one, and then this one. And these are the inside tiles that you also have repeat. So this is layer 2, and then inside of that are all the ones that you can count. So you'd have 1, 2, 3, 4, 5, 5, and then 4, 3, 2, 1 of fully filled tiles. And here the second row tiles are also fully filled, but we can't really be sure of that normally. So I think this would be a correct way to do it. So yeah, I think that would be fun to make. So basically what I would do is go up to step 65, and of course for the real issue, for the real input, it's actually easier than this. So for instance, for the test input, if we wanted to do the 5000 case, let's do 5000 divided by 11. So 454 times 11 is this. So we'd start at 6 in this case. No, 6. Okay. So 6 or any uppercase of that. I wonder if I go at 6, would there even be a stable pattern? Probably not. And we have the same issue for the bigger input, of course, because if you go to step 6, let me run this differently. So let's first base it off of the test input for now. Let's take this to step, let's go back 1 to 40 or something, 60, whatever, and make this a bit smaller. I can probably take it down to 4 again. So much writing. It really doesn't like these big grids. Because 6 is like just to the edge there. So I think we would need at least 6 plus 11 for the width. Why is this so slow? I've never seen it print this slow. But yeah, it's fine. Let me see. So I think 17 would be the first possible option to do this. And then we don't have enough info yet. So 17 would be 28 then, I think. So this one would be the first size where we could do the repeating patterns, I think. Oh, let me leave this to print for a bit. Okay. So we're saying you need to have 2.5 times the input size to get your reference start. So 28 would be the start. That would also mean that 39 is the next time. So let me just capture this quickly just to verify. And I think it's correct. So let's go to 39. Here's 39, and if I put those side by side, you should be able to see. Oh, it's a bit too much. Like you can see the same spikes up top, the same shapes, exactly the same way. This is the edge there. Like it repeats twice here, but it should repeat 3 times here. So 1, 2, 1, 2, 3. So I think this is all fine. Then you have the inner ones that repeats twice, where it's once here. So yeah, I think this is the way we do it actually. So let me just see if you can code this up. Do I have it up here? Do I have the 5,000? Let me put the 5,000 one back. Actually, we can do it against the 1,000 one. It's fine. So the strategy for this would be let's see. We have our max steps here. Let's do this. Oh. So we do max steps modulo the grid size, grid dot rows. In this case, rows and columns are the same, so this should both work. Int remain is this console.writeLine okay, remainder from blah with grid size this. Okay, so we have remainder from max steps with grid size grid.rows equals this. And then what we need to do is also our strategy would then be int offset start equals to and this one will be grid.rows times 2 plus remain, like this, right? We should analyze step this, offset start, and extrapolate from there. Okay. Well, grid size 99. Ah, okay. I need to have the original grid size. So this would be raw grid. Did I save that one? Let me see. Because I transposed the entire grid here, let me disable that so that we have the original data. So much to clean up. If false. Okay. Cool. Okay. Remainder from grid size 11 is 10. Is that correct? Yes. Analyze step 32 and extrapolate from there. So yeah, so if we do max steps is 5,000, just because I have those numbers in my head still, it would give us a remainder of 6, 28, etc. Yeah, okay, so this is exactly what I want. So now that we have this, what we need to do is go up to that. Let me see. And now we do like this. We do the offset start. This is the max amount of steps. And now we need to be able to do a few things. What I also should do is actually fix this walkable neighbors part. Because I need to have a modulo for those. Let me think. In this case, I need to actually make the grid size infinite. So that is interesting. So I need to do a grid is new this with. Actually, this will cause me issues. Let me see. Basically, I just want to have it expand in any direction. Because up till now, I already adjusted these to make sure that it works, and I offset myself to have the center in the start. And I could do that. I could just fake it actually and just have the start there. Do I want to do that? I can do that. Let me see. So start would be this. Yes. Let me just fake it here then. So now I can do start is start plus, and we do int grow size 500. So this one should actually, let's make it 50,000. That should be fine. 500,000, why not? That should be enough. And then we don't need to do this. And then we do, this becomes grid.rows times grow size plus 2, same for here. This is grid.columns. Okay, so now we fake our grid. Let's do that. Fake our grid to think it's huge. And this way I don't have to add extra exceptions for all the logic. Because I have wrapping logic and bounds checking logic, and this way it will just allow it, because we will start somewhere clear out of every bound. So this one basically will make it like 1,000,000 by 1,000,000 grids, so that should be enough. The only thing is that I need to change this logic now, because it will have to have a grid offset value. Offset is, and this one would be the old grid. So we do var grid, old grid offset, old grid size as offset is grid.size. Let's do that. And then do it like this. And now we have this version. We do grid location forbidden offset. And actually it would be current offset for here. Yeah, so that I actually don't need this, I just need to offset my version here. Now that I think of it, I just need to actually offset my, see. Like this. Rock locations, I should probably do something like this, and I wonder if I can implement that as well. Let's alter the grid location here and add another operator. So it would be something like this. So we will implement the modulo operator for grid location. And it basically becomes like this. Which is pretty cool. It just becomes so much easier when you have all this structured data to work with. So now every location will be converted back to its origin position, which is nice. So that we can check the rock locations without creating a giant set of rock locations. And I should probably validate that this still works before I actually do this. Okay, let's disable this for now, run the old code. Let's hard code it for now because I will grid location. I wonder if I can cast it actually. Let's make another operator. Int val, and this becomes just val, comma val. So now you can convert an int directly to this. So now this one becomes a grid location with both values in the same direction. So let's enable the old code that grows this true. And let's have a somewhat sane version of, let's do the 100 one, because it's just a simple test. And for 100, I think it was this one that we need to do. I should have like multiple test cases and values, but yeah, let's see. Let's disable the printing for now. So if I run this now, let's see if the logic works. Why am I still printing? I thought I didn't do that anymore. Print column, there's the part one actually. Okay, so P2 is 53. Okay, so this is not working as I expected it to, I think. Let me think. Let me check this just in case. The offset start thing that I did here is wrong. This one still needs to be max steps for now. Which is 1,000. It's funny that this one is bigger. Okay, funny. But it still didn't work for this one. So let's see. The starting location, this will be the first one, right? Okay. So the starting location should actually evaluate to, what is it, 6.6, I think? 5.5, is that correct? It's off by 1, right? Let me see. Yes. Oh no, 5 is correct because yes. Okay, so this one is correct. So this one should give us 2 options here. 5, 4, yes. Ah, and then I need to cast them back. Haha. Ooh, that's annoying. Let me think. So I need to solve this in a different way because the values that I return are actually need to be in relative to this one and not this one, because this is just for testing. So what I need to do is this, and then I need to make sure if option dot like this, and we do this. So I can't take it out there, but I can do the check here. So let's put this back, and now we should get to bigger numbers. Yes, and out of those, 2 need to be not valid. So this one is good, this one is skipped, this one is skipped, and then this one is it. Okay, so this basically makes sure that our logic works. Boom. Let's see, P2, is it too big? Yeah, it's way too big. So what is the issue here? Max steps is set to 1,000, that is fine. So what is the issue here? P2 is still test. 668697, and we should have had... Wait, what am I doing? Where is the answer there? Ah, I'm still off by 1 because I did the bigger example. I didn't change the one with 1,000. Okay, so I didn't break it. It still works. I just did the 1,000 steps instead of 100, so that's my bad. So yeah, basically this logic works. So this makes sure that I don't have to grow the world by too much because I can just do this. So let's put this back, and now it's still work. So now if I go back here and I don't fake the actual world, so false here. So now the grid never gets bigger. Okay, let me see. Sure. Boom. So this is fine. Let's see. Test is true. P2 is not correct anymore. Okay, let me see. Ah, I updated the amount of runs to do, right? Let me see. Max steps. No, it's still 1,000. Okay. Let me see. Let me see. Get walkable neighbors. Current location exclude visited. Why does it do less now? Okay, let me debug this first again. So the first one would be 5, 5. This one gives us 4 options. First one is added. Okay. So where is the issue now? Because our grid should be big enough. So the issue that I have now is that let's see, what is grow size here? Sure, that doesn't matter. This doesn't matter. So basically, now that I no longer fake it, it gives me a lower result, which is annoying. Because the only thing that I changed was this part. I no longer do this. Let me see. If I enable this, what will it do to the grid? Because this one will be messed up now, right? The offset. No steps taken. Okay, so there is something. Let me just see if I just trying to see what is different between those two. Come on. Sequence contains some elements. Okay. Ah, my start offset here. So is the only difference the grid and the start there? Interesting. Stuart, I really like this one. What is your general approach to part 2 so far? Okay, I've went over this at the start, but what I want to do is basically figure out, and I write that out here. Let me see. Before all of this debug output, the remainder from the amount of steps that we need to take, that is the place times plus 2 times the size of the grid will be the start point that we will start. We will then analyze it and break it up into these sections of data. I think I have a bigger one here. Nope, I thought I saved a larger copy. And basically I identify these parts, so what I will do is just once we get to a state, then figure out all these groups and then extrapolate from there. That is basically how I want to do this. I'm just trying to debug something now because the thing that happens here is that when I fake my data, let's see, grid offset is 11 by 11. And what does my grid look like now? Grid. This one is a lot smaller now. So maybe I overdid it with the size. I wonder if I make this smaller, if it takes effect. Because I built something at the start that fakes the entire it fakes the entire map growing bigger. I already turned it into a sparse map that parses out the special markers. And what I did was just have something with a growth factor that will just create all the missing rock markers so that I can still use my part 1 code. And I've written something else now that lets me just keep the original set of a few markers and just use modulo to check if it would be a rock in the infinite expanding universe. The only thing that I need was like the get walkable neighbors here. And actually I don't need to do that anymore because I could just get the directions here. I could just do it even without this option, and maybe that will make my life easier. But for now, I want to know that I want to know why, if I don't do this stuff, that it works. It doesn't work, but if I do fake that part, it does work. So it's a bit strange to me. So start becomes way offset into the future, and grid grows taller as well. And the issue that I have is if I do it like this, I don't get the result that I'm looking for, and I wonder where the difference is there. So that is weird. So for some reason it seems like there is a blocking condition that I'm not accounting for. Which is weird, because if I run this same code with all the fake rocks generated, it does work. So I wonder if this is off. So it's an 11 by 11 grid. So if something is at 2,2, in this case it would be offset to the grid to the right, and it would be at 13,13, and you modulo 11 that, you get 2,2. So I don't think that would be the issue. So what could be the issue here? It's just something that I'm not seeing. So the basic situation here, and this is just a roadblock before I can move on, is this logic here. Exclude visited, it has... That is interesting actually. So is my grid too small here? No, it can't be too small. Oh wait, I think I know what's... I'm such an idiot. Let me see, because I queue up the start here. Ha! So that is my issue. It's always stupid stuff like that. I queue up my start too early before it's adjusted. So now if I run it again, it should work. Yes, okay. So that was the issue here. It's always nice to debug stuff like this. See, this is disabled, so now I don't need this logic anymore. I can just do it relative to what I have there. Let me take away all of those, all of this. This is all debug logic. That one is still interesting. So if I run it now, boom. So I can do the 1,000 steps. It works relatively fast. It comes up with the right answer. I don't fake all the rock locations anymore, so that is good. Okay. Now, let's go back to where we were. Let's take this state. And now we end at our offset start. Boom. Now we no longer have the right answer, but that is fine. Step 32, okay. So now at step 32, what we need to know is, actually no, we do know. Let me just print out this one actually. Is that correct? Let me see. Oh, I forgot that I made the map huge. Yeah, this is not gonna work. I need to be smarter about this. int min range, int max range. Let's do it like this. And we want to have the old grid size, which is annoying. Do I still have that somewhere? Old grid size is off. Great. So now we want to do the offset minus would be grid dot rows divided by 2 minus grid dot row times 4, something like this. Okay, so let's see if we can print out that range just like that. Like this. That should be fine. So let's see if we can print this out. Okay. Okay. So this is the state at the place that we're looking at it. And basically what we said about this, and we have the rock modulo is not here. Let me just make sure that I add to this as well. We do the old grid size, we add that as well. So we do grid location, original grid size. Grid location, offset is current modulo original grid size. Okay. So this one should now print with the rocks. Okay, that looks better. So now our target is, as we know, we went to a state where we would have to have this cross enabled. So we now know that the current center of our universe will be fully filled. The one above, to the right, below and to the left of it will also be fully filled. Then this one will be our northwest first layer, and this one will be our northwest outer layer, which is repeated twice here. We can validate this. This will be north, east, south, west, and the same for the other angles. So this is what we now want to do, is to actually get this as a offset data and see if we can figure this out. Let me think. Let's see. So what we need to do is to get a grid. Int get grid count. Grid original grid. Grid size. And then we have grid location top left. Like this. And then we should probably also have the list of locations that were visited, like this. So now we do int result is 0. And now what we need to do is for int row is 0, row smaller, yes. Wow, the autocomplete does what I want. For int for int col is 0, col smaller than original grid, like this. Okay. So now we can do var location is top left plus row comma col. And I have all sorts of implicit conversions, so this one will be an implicit conversion to a grid location based off of a value tuple. So now I can combine the two to get the actual offset, and I can do if visitor.contains location result, return result. Right, like this. And I actually don't need to store that, I can just do this. Boom. Now it's just a matter of determining the top left of that grid and then getting all of the special locations. Let me see. Because we will have a special object, so let's have a record expanding object. So we have int filled size, int north, int east, int south, int west. We have int northwest 1, int northwest 2, int southwest 1, int southwest 2, int northeast 1, int northeast 2, int southeast 1, int southeast 2. And this is basically all of the layers that we have. And what we then need to do is have the relevant counts. Boom, 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 boom. So if we take this one back into account, so this is like a filled square. This is north, east, south, west. This will be northeast 2, 1, northeast 2. So we need to have a relevant count based to the amount of size that we have. So this is one of size 2, which means we get 2 of these, 2 plus 1 of these on each side. So we do long size. Actually, let's do a long calculate size int iterations. So now we do boom, 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 boom. Just need to make sure, like, if we expand one, it goes one in each direction. So this becomes 3 plus 2 plus 1. So it will be 3 by, I think it's just, let me think. This one becomes 2. So if this one is 3, it will be 3 plus 2 plus 1. I'm getting tired. There's a way to calculate that and I can't think of it right now. So I have to get back to that. Basically it's like for int I is 0, I smaller than iterations I. There's a for, you can type it in chat if you want it. My mind is blanking right now. So you'd have long result is 0L. So do result plus equals I, actually this won't be 1 larger equal I times filled size, like this. Actually this one would start at filled size for the center, which is fine. And then you do plus north plus east plus south plus west, right? So these are the fixed parts. You have the center and the 4 directions, and then you do the other stuff. This is so you have fixed parts, then you have filled center squares, then you have the first layer out connected to center, and this one will be equal to the iterations. So now you do result plus equals result plus equals, and then you do like northeast 1 times iterations. Iterations is steps. Let's see, steps count minus tile size divided by 2 divided by tile size. That's in one direction. So size to the west is to the east. Yes, yes. This one needs to be times 4, by the way, because it needs to repeat in each direction. But what I was saying is, like, there is a way to write like the one that to sum up every number from I to 1 going back. So like 3 plus 2 plus 1, or 4 plus 3 plus 2 plus 1, and I'm just blanking on that right now. But basically you have like for this you have this 2 plus 1, 2 plus 1, 2 plus 1, 2 plus 1. That's what I say, you have the 4 directions, so you actually have to do all of this times 4. Okay, yes. And I can't think of there. I've written it before, but I just can't remember it. And this one needs to be by 4 times 4 for each of the 4 directions. I thought you were looking up for amount of tiles. No, that is fine. So now I need to do these 4 layers. So you have northeast, northwest, southeast, and southwest, and then southwest, and then you get the layer 2s, and this is actually times this plus 1, because that's just 1 layer bigger. Like this. And then we get return result. Okay. So this one should actually be able to calculate the size of any object once we get those numbers. In theory, at least that is my theory. So let's see if we can make that work. So let's do get expanding objects. Okay. Like this. And this one will assume that we have that. So this one will be filled size equals get grid count, top left, comma, original grids, top left, comma, visited. So this one will get the first one. There's no argument giving for file. Okay. So now we can do every one of those, and we just need to have the relative parts to calculate those, right? So if you want to have north, it's just the current top left minus 1, 2, 3 times the grid size. So we can do north is this one, and do top left minus original grid size times 3, right? And I can actually just do this. It's fine. Boom, 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 boom. Like this. This is fine. So now we have north, east, south, west, south, west. Okay, so we have north. South will be plus this. Actually, this is wrong because I need to have just the. I need to just adjust the rows. So this would be row times 3, comma 0. Let me just do it in the proper place. Minus and then plus. And then east would be the column offset to the right like this. So we do 0 offset by original grid size but columns times 3. And then for the other one it's minus 3. Like this. Because if I would do the entire thing, it would offset both columns. So those are those extreme edges. Let's take the layer 1. So northeast layer 1 would be 1, 2, and 1 to the side. So it would be 2, 1. So northeast 1. We need to go up 2 rows, and then we need to do. Actually, I could do this even better to make it a bit more readable. Hold on. So I can do 2, 1. Like this. So then I go up 2 and 1, and I think that might be better to read than the other ones that I have here. So this one would be 0, 3, right? This would be 3, 0. So now at least the offsets and the sizes are more separated, so it becomes a bit clearer what's happening. I know it's still a lot of code, but so this is 0, 3, and then the above is again 3, 0. Okay, so northeast. Used out of position. Okay, Jesus. It doesn't like this. So what would be the next position? Let's see. Northwest. Okay, fine. We'll do northwest. It's fine. Northwest 1. That's annoying. Let me just move all of the let me do northeast, then southeast, then southwest, and then northwest. Just to keep it in the same clockwise rotation. So we have northeast, southeast, southwest, and then northwest. That at least follows the same set of rules. So we have the filled size, we have northeast, southwest, we have layer 1, and we have layer 2. Okay. Let's start with northeast. We had that. Okay. Northeast, southeast, southwest, northwest. Okay, like this. So, northeast. This one is up to 1 to the right. I can do down to 1 to the right for the other. Okay, and now since I'm mixing these, I should probably do -3 and just always do plus. Just so that I can mix signs on the right side here and not get confused. See, refactoring as we're going along. So this one is up 1 to the right, this one will be down 2 and 1 to the right. This one will be down to 1 to the left, and this one will be up to 1 to the left. Like this, so that's clockwise. And now we need to do the third layer, the second layer once. And these one becomes 2. Yes. So this should satisfy everything. Now just let's see how we do it. This one should be 1, 2, 3, 3, 1. I think we'll just take the one next to the angle there. So we can do northeast 2 will be 3, 1, -3, 1. Okay. Okay, getting there. So this can now be a nice arrow function. Oh god. Like this. Get expanding object. Whew. So now that we've done this, is var eo is get expanding object. Amate says, we are all tired, I guess. I just discovered that I was looking at wrong numbers trying to get some sort of pattern. It's actually simpler than I made it appearing before. It's on Discord if you're interested at the moment. Okay. I want to finish this, but I will surely take a look at it. Actually, I can do it now, why not? After looking at the numbers for a few hours, I found that those numbers were wrong. These are the delta for tiles for each step. They do stabilize and seem to never exceed 4 or 5 for test data. Okay. Yes. Yeah, because these are all the filled ones, right? Basically, the 405 ones are the ones that are fully filled. Let me see. Get expanding object. Original grid size, original, I have that one. Don't I? How did I call it? Old grid size is offset, fine. Top left, it would be start, minus, start modulo old grid size is offset, like this, and then we have visited. Okay. So I wonder, console.writeLine. So let's do for int I is 1, I smaller than 10. Increment I. Let's print out these numbers and then see if we can verify them. Just need to come up with an idea on computing edge cases, tiles that are not full. Yes, yes. Boom, 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 boom. Iteration blah, and then we do eo dot calculate size. Okay. Okay. Like this. Okay. That should be fine. So this should be step. And then we have offset start plus I times old grid sizes offset dot rows, something like this. I think this is correct. Let me see what happens if I run this. I thought I only had a small number here. Oh, one smaller than 10. Great. I was like, what is going on here? Yes. Okay, let me see. Boom, 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 boom. Is this off by 1? Let me think. Because this is the first time we start 32. This counts as iteration 1. Six of 5, is that correct for? Oh no, that's because we stopped early. That's not the issue. Let me think. Let me see my expansion object. East is 0. Okay, so there are 0 values here, which is not correct. Let me see. I should also have like this offset step. Okay, so let me see. Start is that. This makes sense. That should be the top left. So if I do visit dot where x dot row larger equal to this and x dot row smaller than this plus 11. And x dot goal is larger equal than this and x dot goal smaller than this plus 11. Sure, I got to array. Come on. Okay, let me see. Set next statement. Boom. 81. Is that even possible here? How many? Let's see. 1. This is annoying. 1, 2, 3, 4, 5. Actually, I can just count the rocks. What is the rock count? Rocks. there's 40. So 11 by 11 is 121. Okay, so this is correct. So this one actually gets me the right things here. There should be 81 there. So what did I have in my EO object? Field size is 81. Okay, so that is correct. Okay. It stopped at the correct step, so that is also correct. What could be the issue here? Let me see. Step into. Ah yeah. And now I'm regretting this, but it's fine. 11. Top left is 55,000. This is that. That is fine. Okay, let's step into this one. Get grid count. So this is the first one. Boom. Hello, I made a live. Hey, welcome back, Sunco Software. It's nice to see you. Yeah, I just I decided to go back to streaming because I figured I had a way to knock out part 2. But basically, what I've done is figured out a way to do this and then slice it up into all the special parts. But there is something wrong with the way that I calculate it right now. And I already see what I've done because I've taken all the relevant paths based off of this, but this is actually the shape that I'm doing. So I need to remove 1 from all my numbers there, I think. So this one becomes, yes. So that is the issue here. These numbers aren't correct. For like the north, I need to go -2 and not 3. So this one becomes 2. 2, 2, 2, 2, 2, 2, 2. Let me see which ones these are. So this one will be 1 and 1 actually. So this one would be 1. Just fine. Okay, so let's run this again. Okay, so this is looking better, I think. So now, which one did we go for? Max steps is 1,000. So then the iterations would be 450. No, wait. We should analyze step 32 and extrapolate from there. Modulo. Okay, so let's also do. Let me see. I need to remove this as well because this one can't just be this one. Boom. And then we need to have this offset start. Yes, and so we need to int target iteration is max steps minus offset start divided by grid.rows. Okay. Go on macro steps. Okay. So now I should actually do here. So now we should say this is no longer relevant here because we won't do that. I can just remove this completely and do long P2 equals calculate size for target iteration. Okay. Let's see if this works. Nope. 1312205. I think that's an order of magnitude off, right? No, 113. Okay, let me -1. Nope. Okay, let me see what the issue is here. Iteration 1. No, this is off by 1 as well there. Let me see. Iteration that. So 0. Iteration +1 would then be that, I think. Let me see if I can calculate what the answer would be, like the validation step here. Should be this, and then we do where actually no, this exit value smaller or equal than let's get the step here. Step var step is this. Come on. Step is this. Okay. Is this actually, would this be 6 or 5? Let me see the expand object here. Quick watch. Now at least every value is filled. The filled size is correct. Let's do like a small one. Southwest 2. So southwest is this one. And then it would be, oh, that's not a small one. There's still a lot of them here. So 1. Oh, this is so annoying. Can I do this 1, 2? Let me do it. 1, 2, 3. 1, 2. Alright, this is probably behind the camera right now. Let me just take this one. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So this one should have been 35. Interesting. Ah, northwest 2, 35. Okay. Southwest 2. Wait, did I mix them up? Haha, probably. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7. Probably. So I messed up south and north there. Let me see. Southwest and northwest. Ah, yeah, because that is true, because going south means the number goes up. So I actually inverted these two. Jesus. So I think I need to mix up every sign. Okay, let's just I should probably fix it. Okay, so going up decreases the number. So why don't I have that here? So north and south. South should go up. North is a negative. And then south will increase. North should be negative. Okay. East is incrementing. West is decrementing. Negative, negative. East. West, west. Okay, so now those are correct. Okay. Yes, okay, so now at least the wind directions are correct. So I think that was fine. So now I need to make sure that this part works. So let me see. Calculate size for iteration 0 doesn't make any sense. So let's do it again for 1. So we have this. So for iteration 1, let's pull up the... Do I have a still... I think... I don't think so. It might be in the console. Or we can use this one and get confused. Okay, let me just remove it and just take the print out, create a screenshot, and make sure that I have that one. Okay. Yes, okay. Let's validate this quickly. Boom. Okay. Stop. This needs to run from 1. Because it makes no sense there. Well, I could do iteration plus 1 here. That is fine. I plus 1. Okay. And I need to have actually my breakpoint here. Let's run it again. Boom. Okay. So basically what we expect, let me pull up this one, is we need to have 1, 2, 3, 4, 5 times a filled square. So this is ones here, and then all the north, east, south, west ones. So the empty cross with just these we have now done, and now the iterations. So basically this becomes 1 times fill size times 4, which is fine. So because this one is, it's marking this one, this one, this one, this one. So this is fine. Then it needs to do, let's see, it does the layer 1, that would be this one, it needs to do it once, this one, and this one. Then it needs to do the side layers twice, and then it should be correct, right? Why is north, east 2 is all 82? Okay, so those are actually off. Let me see. Quick watch this. So the problem here is that northeast 1 and 2 are fully filled. Same for northwest and southwest 1. Which should not match up with the screenshot that we have here. Oh, actually they do. No, that's fine. It's actually fine. Only the southeast one should be not 100% filled, and the other 3 should be filled actually. So yeah. But the north, is that one correct? Let me check. Because it says the northeast second layer, which would be this one. This is incorrect, so I need to check that. But it's correct that 3 of those, only the southeast one should not be fully filled, and that is what we can see here with the 72. But the north northeast 2 is incorrect. So let me see the mapping there. Northeast 2. Yeah, this one needs to be 2. Okay, let's run that again. Boom, 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 boom. So I think everything there was fine now. And the question is, we should analyze step 32. Yes. So for iteration 1, 32, it's too high here. Because if these are like 81, so let's say everything is 100. So this would be 900 and then a little bit extra here. So you could never get to... Actually, it's not that crazy. Why do I have this one here? Ah, because we only should... yeah. Now the thing that I forgot is that we only do the modulo 2 parts. So that's something that I forgot. So yes, it is correct. There are 1179 paths there. But they don't have an even or odd number of locations there. And that is because it alternates. I forgot about that, which is a pain. Let me think. Because like the paths for this one, for the center one, that end up in even steps would not match the one above it in even steps. So that's a complication that I didn't account for, which is a pain. So like every square that is diagonal will be matching, but this one won't be matching. Stuart asked, could you make the code larger? I can, but it was already at 121%. So the visible area of the stuff that you can see is starting to get really small. So that's a complication that I didn't account for, because basically to be able to do the calculations now, I need to... Well, I have all the data here actually. I was smart enough to pick a stable that has all the data that I need, because this one is the center one, then this one you can take for the odd number. Let me think. Yes, so let's do this. Okay. Location to test, then we get to test is this. And now we need to make sure that to test, let me see. Bool even, track even, let's call it like this. And in this case we want to know try get value out var step like this. Let's see, I need to have it one closer here, right? Try get value. Here we do out int step, and is that not correct? Is it a long? I need to actually have the dictionary grid location, comma, int like this, visited, and step modulo 2 is, and then we get track even, 0 or 1. It becomes really messy like this, but only if these two match that we want to track them. Yes. And now I'm thinking this always needs to be, let's see, bool track even, like this. I need to pass these to all the sub things here. This needs to be the dictionary like this. Okay. Because we only need to count the ones that are like this. And the worst thing is that I need to, for all of these, I need to have both versions now. I need to have 2 versions for these, I need to have 2 versions for these. And depending on how many we have, we need to count the one or the other, which is a pain. Let me also field size, int field size odd. Let me just call it B. And this one will need to be offset by 1. Like this. What is the complaint here? That I need to have an extra brace here. Because this one then, depending on how many steps outside I need to go for every level, I need to take like the odd, even, odd. So for like the first one away from the center, I need to get the B version, then I need to get the A version, I need to get the B version, the A. So I need to alternate that in every direction, which is a pain. So I need to have a nested step here. So I will still need to do that here as well. It's not a fun challenge anymore. Let me get this one here. Okay, I need to pass on the other one. This one becomes steps taken and then true test in this case. Because if we are testing, it needs to be odd, and otherwise it needs to be even. So yeah, so I'm curious. Actually, I can just step out, shift of L like this. Oh wow, wait. Oh yeah, I was like, where is my 81? But no, these are the numbers. So you can see here that for the center tile, it will be 42. For the one directly adjacent, it will be 39. And then the other ones adjacent to those will be 42 again. So yeah. So now I need to have B versions for all of these. Which is a pain. Let me run this because I don't know. This is the version that we do. So I don't have, for this one, I don't have the B version available. which is a problem. Actually, what I could do is do the same and then just do the opposite there. Is that correct? No. I was just wondering, like, can I just shift over? Wait a second. Let me think. These do amount to the same number as before. So yes, if I just call it with the different odd-even rule, I'll get the other ones. Is that correct? Or am I cheating myself here? No, because the current values in those slots are actually different right now. No, actually. Yeah, the physical numbers in those places will be different. So if I have a partially filled, if it's fully filled, it doesn't matter. I could do that. I could just switch to calling the odd rule. No. Is it true what I'm saying? Because the same squares will be filled, but then I need to have they will be filled invertedly. Right? Because what I'm thinking is if I could just call this one again and then get the odd numbers, but the thing is that the values will be switched for them because they're connected to each other. The grid size is odd, so it will toggle. So I'm just thinking if I need to do another step above this to make sure that I have the full data. And I think that is the safest option, but I could actually just validate it. Because I'm worried about this one here, the south, like the south west one here. The funny thing is that they hold the same values. Alright, that's because they're... Ah, no, I'm wrong. Never mind. I only need one. I'm an idiot. Sorry, cancel everything. Because they repeat diagonally, I already have the correct one. There's only one version ever. So, never mind. It's just the ones that don't repeat diagonally, which are these inside ones. So I was making things too complicated. My bad. All of these are fine because they repeat in a diagonal pattern, which means there's always a one off. There's never an odd even problem here. Okay, chasing a ghost. So basically with the change that I made now, it's actually already correct because we have the B one. Now I just need to make sure that how I do this. Because basically the rule will be, I need to if this is the if it's the shape like it's like half plus 1 is A and then the other one is B. So if I round it down like that, it would be fine, right? Because if I add another layer here, no, it's not. Because if there's another layer here, it would just expand outwards. Let me see. In this case, there is just one center and 4 Bs. in that case it becomes 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 4. Just trying to work it out. It's just I can't think straight. Because basically you have like these let me just draw it out. So what I need to figure out now is if I can easily calculate how many of each that I need. Let's just make it bigger. And I can actually, can I fill the back one with red as well? Boom. Boom. So this is one case, and then there's one where you have like the cross. And then there's one where you have that just in many layers. And there's always like this one. It's looking kind of extra like this. And if I grow this out, it will boom, 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 boom. Like in this case, there are 1, 2, 3, 4, just 4 adjacent ones that are B's. But if I take the other case around here, it would be there would be a B here and a B here and a B here and a B here. And a B here. Oh, you actually add a new ring. So in this case it's one, like the iterations would be 1, 2, I would call this 2, right? This would be 3. So for 2, it's actually boom, 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 boom. So if the iteration number is even, it will be an outside ring of the A types, and if it's odd, it will be an outside ring of B types. Can we determine how much that would be? So for 3, it's like 4. No, it will be 4 times 3 in the outside edge that gets added. So it's 1 times 4, then 3 times 4. Yeah, I think that's the math, right? So in this case, it's 2 times 4. I know if it's the, yes, it's 2 plus 2 plus 2 plus 2 plus 1. Yes. Let me think. So for each iteration, if I modulo 2 is 0, even, else, odd, B on outside. Actually, odd is just a B ring, A ring, right? This was already the logic that I had, so yeah, it wasn't that hard. So if it's like this, and otherwise we do the filled size B times 4. Okay, that took way too long to figure that out. So everybody's still alive, everybody's still enjoying themselves. Let me know how you did, if you did the challenge for today. Did anybody finish it yet? So now this should be correct. Let's see what it spits out if I run this. Oh wow. Let's see my code. What did it spit out? 605. It should be 605. Woo! Nice. So now it actually works, which is kind of scary. Except that we can't actually extrapolate further there, I think, because we don't have the data for that. I haven't been able to do any puzzles. Oh yeah, you said that. Sorry, man. I know you like to do this as well. Over your skill set? Nah. I'm pretty sure you've done Advent of Code in the past, haven't you? Let me see. So step 1, at least this should match. And we can just do this. Iteration 1 step, and this one would be offset start. And then we do just 1 should be steps taken, and this would be offset start. Boom. And now I wonder, when the puzzle get into grids, I struggle. Well, that's something that you can learn. I also learned that. Let's see, what is our answer here? Answer P to test minus this. We're off by 14,000. Haha. Okay. Well, not okay, but it's something. Do we need to have one more? Quick watch. Now we're off by 4. Okay. Interesting. So what could this be? We're so close. Let's see. I want to know what it does if I do the 5001. Sure, 5001. Oh, this is close. Let's see. P2 minus this. No, not P3. 70,000 off. What could that be? What could that be? Wait, what? Ah. that makes sense. Test answer P2 test. Okay, so it's the same off by 4. So I think we need to +1 on the target iteration and then -4. And I don't know why, which is not good. So target iteration becomes +1. Okay, so this is super cheesy, but let's see. This should now work for 4,000, okay. For 5,000, and we should also do it for the other ones. And I should probably just put this into, let's do long calculate int steps, yes. So, and to do this, what we need to do is we have the max steps, we get this stuff, target iteration, let's call this max steps, and now just call it steps, like this. Let's refactor this all a bit. This is all fine. Test is no longer needed. Well, I can comment it out, but it's fine. We can remove this here as well. So this will need to be grid location like this. Steps taken will just be that is something that we need to pass along. That is this, like this, boom. Actually, we want to pass in the steps first, because that is what we want to calculate. Is there something else that we need to pass? No, so we can just do return PO dot calculate. Actually, we can just pull in this, right? Wow, it doesn't matter. We can do it like this. No, I actually want to pass it in. You should try this on copies of the real input instead of Excel. Yes, I will do that. I'm just refactoring it now so that I can validate once more that all tests work, and then I will move to the next step and then run it on the test on the real input. But I can't validate. It's distinctly more sparse. Yes, I know. Yes. This one would be target iteration, like this. Okay. Expanding object like this. Okay. So this should all be fine. This is good, and then I can do debug.assert po.get no calculate. So this was 50 EO old grid like this, and steps taken. Actually, I don't think I need to put in steps taken there at all. It just needs this. The whole should be doesn't matter. And I also don't need to do that. I just need this. I also don't need this actually. I can just do this. let me now get these here. If test. Okay, so we have 6, and I can't do things that small yet with this code, so I will probably have to have like a case for that as well, but it's fine. 100, 500, 1000, and then 5000. Okay. Moment of truth. Boom, first one is wrong. Haha, great. Wait, what? Okay, let's skip over the first one. It's too small anyways. Why is everything minus 34? Okay, there's something wrong here. This one should actually work as well. So let's just step into it here. -1, wait. Offset start, okay, wait. Ah, okay, I need the original. Target iteration. Like this. And this again, it's like it's from where I use those values before I increase them. So let's set next statement. So target iteration is 3. Okay, at least now there's some logic coming out of it. Let's see if it works. No. The first one works. That is at least something. So what does the second one say? Oh wow, that's off by a lot. That's not good. Okay. That one overshot by quite a bit. What seems to be the issue here? That's funny. Well, let me think. Actually, I can. Let me run this again because I print out all those values from before. Let's see. But in this case, we want 50. So what was different here when we set this up? Do I still have max steps here? Let me see. Workable neighbors, get expanding object. This expanding object should be all set up, and this was based out of, let me run this again here. Yes. Yes. So why was there an issue? If I run this now. Okay, this one spits out the right answer. This one doesn't. Okay. So it was just a fluke that the other one worked. Then why did my other example work as well? Let's see, for 50 it works, and for 5,000 it works. But for 100, 500 and 1,000 it doesn't. So there is something different for those, which is a pain. Ah, I know what's wrong. I think. Because I need to like my offset is different for those, for the other ones. I need to actually build up this entire piece of code every time, which is annoying, I think. I think that is actually the issue here. So I think I actually need to do this inside the other function. Yes, I know. But I still want to make sure that my code works. I want to validate everything that I can before I move on. Current. This. I don't need to have this set up here, but I do need to make sure that this one happens. There. I need to set up the visited there as well. We're getting there, I promise. Steps taken is, didn't I set this up here? No, that was the visited one. And I actually keep a double track here, so I shouldn't, I only need to do one of these actually. So I should be able to get rid of another one. Okay. Let's see. Boom, build there. Okay. EO does not exist. Yes, I'm aware. Sorry. P1 is this one with target iteration. Okay. No. Like this. Okay, let's go back. Okay, let's stop. And it was still complaining. It's still not right. Okay, that's annoying. It's the same issue, so it wasn't the fact that I needed to start at a different offset. Now the 1000 one is correct, right? Because the 1000 one and the 5000 one are correct. But the 150 are not, which annoys me to no end. So this one doesn't pass and this one doesn't pass. Oh, actually, that is interesting. I just need to have the steps actually that I need, not the target iteration. So this should just be max steps here. Sure. I can try it on the real input. Let's do that now. And let's not print out this thing at all. Whew. I never even filled in answer P1, that is fine. That's a big number. Am I worried that that overflows? Maybe. Too low. Okay. Okay. Well, given that some of the test examples don't work, it was to be expected that there is something off. Let me think, if there is something else that I can do. Actually, the issue could be that this doesn't grow enough. No, we get the same answer. So the virtual space there is big enough. Actually curious to see what it will do here. I should actually record this one just so that it won't stop. That was my part one. So P1 answer is this one. Let's see. Sure. I'll run again. The remainder is 65. Offset start is this. Sorry. I should probably actually just print out. It will be so big. Let's be crazy. Let's print out the state where we expect it to. I'm not sure I can make my console small enough. Actually, did I see something green already? So the space that I'm printing is too large probably for this. But yep, I did. What do you mean by yep, I did? Sorry. Actually, I can do just 2 in each direction, I think. Let's try and see if I can... I still think the print space that I've printed is too big to actually find it. To see my marked output. Let's see. So there should be something green in here. At the center, but I don't see it. So like here in the middle, it should be, there should be some green marker, but it could also be that it's just like the console is too small. Nope, I don't see it. Okay. Stuart said, yep, I did, but what was that about? Curious. So for me now, the problem would probably be fix me 100 and 500 don't come up with the correct answer. And the thing that I actually, what it could be, is that the shape that we print out, that like my edge algorithm, that it overlaps into more than just the perfect squares that I think it would. I feel like we're very close, but yet so far, far away. So let's go back to test actually, and let me print out the... I want to see the edge cases that don't work for me. This one was ×4 in the old code. I just wonder if I'm missing something here now. Come on, run. So like my path printing is also wrong here. Let me see. Offset starts, wait, what? Ah, okay. But grid.rows, and how do I have the visited one? Steps taken. Why is steps taken? Ah, okay, never mind. I was actually visualizing in the wrong thing here, because steps taken is now extrapolated here. Okay. So here is the issue. It actually, okay, what is the last one that it prints here? For 50 it came out with this one, which is fine. This one isn't though, because it only has a stable center state and these ones aren't mature enough. Let me see. I should... Boom. So for this last case, it should say the remainder is 1, step 23, so that is just too early. Let me think. This one works. This one is step 28. So should like the minimum distance be 2.5? And if it's not 2.5, you just add one run more. I think that is the issue here. But if we do that, then I don't know if you can still consider, yeah, probably. Let me check. Offset start, plus remain. If remain smaller than divided by 2, remain plus equals old grid size. Boom. Now the first one doesn't match. Cool. Let's see. So this one now is one whole size too big, because we have 2 to the side here and we only need 1. Right? Let me see. Step 39. Nineberry. You said smaller but wrote larger. Okay. Did I? Okay, my bad. Thanks for catching my mistake, Nineberry. Let me see. Calculate. Yes. Great to have you here, by the way. Always there to catch my mistakes. Boom, still wrong there. So let me see. In this case, it elected 34, which is fine, but now you see that it goes out of bounds here. Okay, so this is an annoying problem to solve. I'll be gone again. I haven't solved part 2 yet. Just wanted to see whether you're onto something. Well, actually, I have working code that works for steps 50 and for 5000. It works, and it uses like this thing that I said before. The only problem is to neatly end up there, you have to start at a variable input, and you can have stuff like this where your edge facing sides are not the way you want them to be, because these ones aren't perfectly filled yet. So these patterns don't work as you want them to, at least as how I want them to. And I'm not sure if I can actually, because this one will always repeat in the same way, grow in the same way. So this will just be an error or a problem that exists. And while this actually repeats like this, it can be a pain. Because what I probably need to do is consider not just this tile, but the one to the left here as well, and make sure that I catch everything like going out there. So let me see. So yes, I have something, but it's not perfect, sadly. So let's bring it in here. I see, good luck. Yeah, thank you, mate. So what I currently do is that I stop at this edge, but I actually need to make sure that I just expand it this way. And then same for like having this repeat. It needs to be this. No, actually like this, sorry, like this. I don't need to have that. I need to do this. And this one repeats here. And then for this edge, I need to have it do this. But that means that you have a corner piece here that won't match up. Right, if you do this, then you have this remainder here, which is annoying. And that's not something you can just solve, I think, because you will need to do... Now actually what you can do is you just take this full edge and then shift it over one, but then you have some duplication there, so you can't... you can do this, but then you have to transpose this onto this and see what the overlap is to get rid of it, to do the proper math. So if I use this, I can still do the same thing that I do now. But it just gets a little bit more complicated, just a tiny bit. So you'd actually have this edge and then you repeat the same way, the same thing over here. But you have to deduplicate this one. And then you get your straight angle here again, which is fine. Like these are okay, you just have to make sure that it keeps going in that direction. Boom, 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 boom. So you have to take 2 squares actually. We have the code for that, so that is fine. You can easily solve that. This code stays the same. But for this one, we also need to do like this. And then you need to, determine the overlap between these two. And this one will be like a plus remaining value. Yeah, so you need to take this one and then, yeah. So how you could do is just take 2 blocks up and take the one to the left here. So let's say you take these 2 and you also take a sample of this one. You need to remove this one from the things that you add, I think. Yes, so you need to have these 2 times the amount of sides and then you add one of these in the end. Yeah, because if you add this one and you put that here, this one will be counted by this side that you have here, but in the end you need to have one more. So you need to calculate this one and have that as an extra remainder. So as a possible remainder. So I think everything can be the same as it is now. So let's implement this. And if this doesn't work, I'll call it a night because it's getting quite late. So our object needs to have, for the second layer, it needs to have a remainder. So we do, I'm off to bed, almost 23 already. Yeah, I know, it's getting late. So no worries, Amarthe. Thanks for keeping me company. It was nice to have you here. I will stream for a bit more to try and see if I can add this logic as well. And if it doesn't work, there's always tomorrow. So thank you for keeping me company, and I hope to see you again soon. I'll post on the Discord what the end result was. So let's do int. We do any 2r. I'm getting very creative with these names, but so these are the remainders, the possible remainders for these. We need to also adjust the north, east, south, west ones like this. And let me see. So north needs to have an extra one plus this one, and this one becomes a -3. Sorry for the small code right now, but I need to make sure that I that I can copy paste and not lose track of the data here. So okay, so this basically is our expansion for the corners, or for the wind directions, right? Now, for the first layer, which is these, we don't need to change anything, but for the second layer, right now we just go, we take this one and this one, so the extreme versions here. So that one needs to also have the one added to the top. Which is, and then the one to the right will be the remainder. Which they should be equal, I think, but let's just, let's see, northeast, so that is to the top. It needs to get the one above it as well, -2. The southeast needs to go down one more and have that added. Southwest, let's see, same like this. Oh, I'm doing the first layer, damn it, I don't need to do these. I need to do the second layer. So that was west, okay, my bad. This one. Yes, I need to go to 3. That makes more sense. Okay. So we extend out that way. Okay, so these are now these sides elongated. So what I've done now is that I've taken this like this, and now I need to take this as the remainder, which should be a carbon copy of this actually, but it's should be fine. B1, D1, yes. So I've taken these rows, and now this one should be the added one. Let me see, is this the same? Yeah, I need to check this one here. Same for... Yes, you need to go out just one. So for here it's like this, and this one will be empty, so it's fine. Am I looking in the right direction here? Let me see. I've written so much over it that it's hard to see for me now. Let me see. We have this one. In this case, it's just one outside of it, so that is fine. For this one, I would track 2 down here and then 1 to here, and it doesn't happen. So for this one, there is no remainder. For this one, I would do the same. I would go 2 down here, so there's a 1 check, 1 there, and there's a tiny one here. Is this the correct pattern? 2, 2, and then yes. Okay, because this is still part of that square, so there's one out of bounds here, just like here. So that would be the one that we catch. So yeah, I think this works. Yes. Okay. So now we need to have the 4 out of bounds ones here. So let me just do it like this. R, like this, and now we just need to have the extended one and move one to the side. Let me see, like this. Let me see, it needs to go 1 over, so this one will be like this. So these are the remainders. And now basically these values need to have the remainder subtracted and then multiplied and then added one back. Let me see. So basically we need to do like this, and then the whole thing needs to have it added once plus n e to r. Basically this is the way to do it now. N is to r, w plus n w to r. So we add them all up without the remainder, and then we add one of them to cover the overlap that doesn't get adjusted there. Minus SW to R plus SW to R. Okay. What's the issue? I need to have a closing bracket here. Okay. So I think this should be the... Yes, you can stop now. So this should now, I think, cover all the other cases as well. Let's hope so. No! Okay, let's see. 6, 5, 3, 2. Ha, and now the off by 4. So now the original value works. And the minus 4. Ah, could that be that there was one? I think that might be the issue there. It was just one that it wasn't capturing. let me not print out the answer there. Okay. Let's see. Okay, this one is 4 too high, so I have to investigate what that would cause. This one is correct. This one, quick watch. Close, but no cigar. So this one is probably also differently shaped, where I need to do more to catch all the irregularities. This one is 4 too high. So this one would work now, or would still work, and then this one is all still too far. Okay, that's funny. So I've solved something, and I think that I'm in the right direction, but it's getting too late, and I probably should go back to printing it now. So let me just look at it once more and see if I messed something up there. I think I'm good, but okay, so for the first one, like for here, there's one that's not filled in. So this one isn't a perfect square right now. So that means that this state of 28 is too early. And this is like one of the issues that I saw before. I can't trust this state yet. So I should probably have an extra layer there. You had asked who finished. Okay. Yes, okay. Congratulations on finishing. Yes. I'm very, very, very close. So at least I found my off by 4 error, because that was counting this hole here 4 times, because the pattern wasn't stable there. So if I run this now, so the 100 one, it worked, and now this one. So let's see what the issue could be here. And it was off by, I think it was off by a bit. So 16704 minus, it's missing 447. That's a lot. So it's missing a lot there. And if this is the stable state that we're looking at SAP 27, let's see, it would consider, so there would be 2 missing here. The rest would be fine. It would be able to do this. It would be able to do... Okay, this is the in corner, this is that corner, that is fine, that one is fine, that one is fine. I don't see the issue here, really. Yeah, I can see actually. I can see the issue, because this one, it wouldn't repeat like this twice, I think. If I take the next evolution of this, I think I will get It's these holes that are messing it up, I think. Because I would like to see actually the step 27, the next one, that would be 38. Kind of want to see the 38 now. Because what my code does is it takes this one and it was repeated here. And I wonder if that is true. Probably. I'm not so sure. Looking at this, if that would be the issue. For here, it would take this as south. This one would be the level 2 layer. This one would be the level 1 layer. I think there might be a lot of edge cases to find where I won't make this work, sadly enough. Do I see something else? I don't think so. No, I think I'll call it for now. I think I need some rest, sleep, maybe come back to it with another idea. I liked my approach, but it's very hard to make a general solution for this. I'm close, I'm really close. But it's just not where it needs to be right now. No. Now I kind of want to know because if I can pick my spot. I'm just thinking if I would do the math for multiple steps, if I could make a better prediction there. Because I can analyze the state and then calculate how it grows. That's not the issue. So if I would actually do the incremental steps from this state, I could probably also calculate like the impact that it would have. Yeah, I think I need to get some sleep and come back to it. It's been fun. I really like it, and I think you've done some cool things. But yeah, it's just too sad that we can't get the answer right now. But I had fun. I was happy that I could revisit this. So yeah, I'll probably take another stab at it tomorrow. And if not, I'll take another direction. But yeah, it's good. I've written a lot of cool code, I think. I'm happy with the stuff that I've written. And I've extended all my classes that I wrote for grid navigation, etc. Like added more operators, and yeah, it's becoming more and more useful. So I like it. The code is now a mess. It's over 700 pages with most of it commented out, but it is cool. I had fun. I hope you had fun as well watching it, seeing some of the stuff that I do. Yeah. So yeah, I'm gonna get some sleep and go back to Advent of Code day 22 tomorrow. So hopefully see you tomorrow, and if not, well, thanks for keeping me company today. Have a good one.